let's start the basic definition of the fluid mechanics, guys. Actually it is derived from continuum mechanics. Okay, the word you need to remember, guys, continuum mechanics. Will come back later and we'll learn about the continuum mechanics also. First of all, the basic definition for fluid mechanics is what? Let's see. Fluid mechanics, if you want to learn, you need to learn about another mechanics, that is engineering mechanics, guys. Engineering mechanics is a science which deals with the behavior of all the matter. Engineering mechanics is the science which deals with the behavior of what, guys? Matter, bodies, you can remember, bodies. And bodies are basically classified into how many types? Two types. What are the two types of bodies? First one is rigid body. First one is which body, guys? Rigid body. What is the meaning of rigid body? Rigid bodies cannot be deformed, that is non-deformable bodies. Have to focus and try to remember, guys, what is the meaning of rigid body? Rigid bodies are non-deformable bodies. Non-deformable bodies. That means they cannot deform. That means what is the meaning of deformation? Change in dimension. So deformation is equals to what? 0. Change in dimension is equals to what, guys? 0. Change in dimension by original dimension is called as strain. So what is the value for the strain? Strain is equals to what? 0. If I draw a diagram here, observe stress versus strain diagram. Let's say this one is a stress, let's say this one is what? Strain, guys. Strain value is equals to 0, but stress is going on increases. Stress is going on increases. You can observe this is which axis, guys? Y axis. That is stress is going on increases, but strain value is equals to 0. This y axis is representing which body, guys? Ideal body. What is the meaning of ideal body? Ideal anna, perfect body anna, or rigid body anna, all are what? Same. Rigid bodies. Rigid body, guys. That is stress is going on increases, but strain value is equals to what? 0. Stress is going on increases, but strain value is equals to 0. That body is called as which body? Ideal body, perfect body, or rigid bodies. Actually, there are three types of rigidities, that's also you need to remember. But basically you need to remember first of all now what is the meaning of perfect rigid body. Okay. The next type of bodies are which bodies? Resistant bodies. Which body, guys? Resistant body. What is the meaning of resistant? Deformable bodies. Real bodies. Real bodies are which bodies, guys? Resistant bodies. They will deform under the application of loads. Let's talk about the matter now. How matter can be classified based upon, let me write here. First one is solid and the next one is what? Fluid. Next one is what, guys? Fluid. Now, the science which deals with the behavior of bodies is called as engineering mechanics. The science which deals with the behavior of only solids. Science which deals with the behavior of what, guys? Only solids. That science is called as solid mechanics. That science is called as what, guys? Solid mechanics. Have to focus and try to remember the names, guys. Solid mechanics is the science which deals with the behavior of solid only. Fluid, the science which deals with the behavior of what, guys? Fluid. That science is called as what? Fluid mechanics. The science is called as what? Fluid mechanics. And we know there are two types of fluid. How many types of fluids are there? There are two types of fluid. One is incompressible fluid. One is incompressible fluid. And the other one is what? Compressible fluid. Another one is what? Compressible fluid. What is the meaning of compressibility, guys? Change in the density. What is the meaning? Change in the density. Incompressible means what? Density remaining constant. Density is what? Constant. Density cannot change. Density is what now? Don't tell me mass by volume. Mass by volume is okay, but what is the meaning of density? Density is closeness with which the atoms are binded. The distance between the molecules does not changes. Density remains what? Constant. Density is what? Variable. Density changes. So for which material the density is constant and for which it does not, guys? Incompressible is for liquids. Liquid is assumed to be incompressible, whereas gases are assumed to be what, guys? Compressible. Now, the science which deals with the behavior of liquid science. The science which deals with the behavior of what, guys? Liquid. That science is called as dash. That science is called as hydraulics. The science which deals with the behavior of liquid is called as what, guys? Hydraulics. And the science which deals with the behavior of gases. Gases science is called as what, guys? The science which deals with the behavior of gases. That science is called as pneumatics. That science is called as what? Pneumatics. Focus, guys. Focus and try to remember. So the science which deals with the behavior of fluid, that science is called as fluid mechanics. The science which deals with the behavior of only liquid, that science is called as hydraulics. The science which deals with the behavior of gases, that science is called as what? Pneumatics. Okay. Next one, fluid based upon their rest and as well as motion. Let's go in detail now. Fluid under water, it's a inertia. Let's talk about it, guys. Fluid under rest. Fluid can be under rest. Fluid can be under what, guys? Motion. Motion with consideration of force. Motion with consideration of force, and motion without consideration of force. Motion with consideration of force and motion without consideration of what? Force and masses. The science which deals the behavior of fluid under rest condition, that science is called as what? Fluid statics. Static word itself indicates, guys, statics, rest. Now motion with force. Motion with force, it is called as fluid kinematics. Have to focus and try to remember, guys. Fluid with force. With force is kinetics. With force is kinetics or dynamics, guys. Without is called as fluid kinematics. So there are three sciences which we need to focus now. Fluid under rest, fluid under motion with force, fluid under motion without force. It is fluid statics, fluid kinetics and fluid kinematics. One more time, let's try and remember, guys. First science is engineering mechanics. Engineering mechanics is a science which deals with the behavior of what? Bodies. Bodies are classified into how many types? Two types. What are they? Rigid bodies, resistant bodies. Rigid and resistant bodies. And note point also to remember, guys, here there are three types of rigidities. One is axial rigidity, one is flexural rigidity, and the last one is torsional rigidity. Three rigidities you need to remember, okay? What are the formulas? Axial rigidity is called as AE, flexural rigidity is EI, and torsional rigidity is GJ. Actually these are related with strength of materials concept, guys, but here you can remember also as we are talking about the solid also, okay? So rigid, non-deformable bodies, deformation equals to 0, strain, change in dimension equals to 0, strain value equal to 0. Over the stress versus strain axis, ideal body, perfect body, rigid body is represented with which axis? Y-axis. Next one, resistant bodies are all real bodies. Basically the matter can be classified into two types, one is solid, another one is fluid. Science which deals with the behavior of only solid mechanics. Solid mechanics you can remember as strength of materials also, okay? Strength of material. The science which deals with the behavior of only solid is called as strength of materials. The science which deals with the behavior of only fluid is called as fluid mechanics. Again, fluid can be classified into how many types? Two types: incompressible fluid, compressible fluid. Incompressible is liquid, compressible is gases. The science which deals with the behavior of only liquid is called as hydraulics. The science which deals with the behavior of gases is called as pneumatics. And three unnai manaku. Okay na? First one is what, guys? Fluid mechanics. Fluid mechanics lo classification: liquid okate, gases okate. Liquid ante hydraulics ani gurtupeట్టుకోవాలి, gases ante pneumatics ani gurtupeట్టుకోవాలి. Again, fluid can be under rest, motion with force, motion without force. First one is fluid statics. Motion with force ante em ostadi? Kinetics or dynamics ostadi. Kinetics or dynamics ostadi. And at last without force ante enti cheppandi? Kinematics. So ee vidhanga first introduction we have completed, guys. But what is the proper definition of fluid mechanics? Continuum mechanics nunchi manam nerchukovali. That definition we are going to see in the next slide. Chalo, pause the video and note it down, guys. Observe, guys. Now, what is the proper definition of fluid mechanics? Fluid mechanics, it is a branch of, make sure, guys, you people are writing while the explanation is happening, okay? Simultaneously you need to write. It is a branch of continuum mechanics. It is a branch of what, guys? Continuum, NWM, continuum mechanics. Sir, what is the meaning of this continuum mechanics? Let's try and understand first. Continuum. Continuum means continuous. This word is, everyone is might aware of this word, guys. Continuous. Continuous means what? Without any voids. What is the meaning of, sir? Voids, gaps. Without any air pockets. Or simply you can tell without any cavities. But if you compare a liquid material with solid material, solid atoms molecules are closely packed. Let's say this is solid, guys. let's say it is liquid now. Liquid molecules are what? Loosely packed now. Liquid molecules are loosely packed. Sir, in between the molecules, do we have here gap or not? Yes, molecules are having gap. If molecules are having gap, then can you regard that material as a continuous material now? No, we cannot regard that material as a continuous material, because gaps are there, because air pockets are there, because voids are there. So, there must be one assumption. What is that assumption, sir? That if a particular limit వరకు ఏదైనా మనకు గ్యాప్ ఉంటే ఆ గ్యాప్ ని మనం ఏం చేయొచ్చు? నెగ్లెక్ట్ చేయొచ్చు. So what is that limit which defines that this much gap can be what? Neglected? That limit number you need to remember as non-dimensional number. One non-dimensional number is there, guys, that you need to focus and remember for the first time we are learning a non-dimensional number. Non-dimensional number is this one, Knudsen number. This number you need to focus and remember, guys. Knudsen number. Knudsen number is equals to formula. Let me write it over the board, guys. Mean free path. Mean free path, or it can be regarded as free length also. Free length divided by characteristic number divided by characteristic length. Characteristic number, characteristic length, guys, it is okay. Now the question is, what is the meaning of mean free path or free length? This mean free path or free length is distance between the molecules, guys. Distance between the molecules. Distance travelled by one molecule to strike or to touch or to transfer its energy to the other molecule. That distance is called as mean free path. Let me write it here, guys. What is the meaning of mean free path? Mean free path is distance travelled by one atom or molecule to strike another one, another molecules. Okay, this distance between them, let's say it is denoted with A. Okay, and what is this free length now? Free length is the size of atom B. So let me write it here, guys. What is the formula? A divided by B. A is the distance between the molecules, B is the size of the atom. Okay, so this Knudsen number value must be less than 1 by 100. That is, Knudsen number value must be lesser than equal to 0.01. This is that limitation that you need to remember. And atom size, molecule size must be what, guys? 100 times of gap, or the gap is 1 by 100th part of what size. Atom antene small, molecule antene small. A molecule లో 100th part gap ఉంటే మనం ఆ gap ని ఏం చేయొచ్చు? నెగ్లెక్ట్ చేయొచ్చు. Gap ని ఏం చేయొచ్చు? నెగ్లెక్ట్ చేయొచ్చు. So if the liquids are having very less amount of gap, so someone is going to ask you how much less that its gap can be neglected. You need to answer what? Based on the Knudsen number. If the gap value is 1 by 100th part of the size of the atom, size of the molecule, then that can be what? Neglected. And the value is Knudsen number lesser than equal to 0.01. Concept of continuum holds good. Concept of continuum holds good. Let's try and understand one more time, guys. What is the fluid mechanics definition? Fluid mechanics is a branch of continuum mechanics. What is the meaning of continuous? Continuous is without any voids, without any gaps, without any air pockets, without any cavities. కానీ లిక్విడ్ లో సాలిడ్ తో కంపేర్ చేసుకుంటే, ఇఫ్ యు ఆర్ గోయింగ్ టు కంపేర్ ద లిక్విడ్ అండ్ యాజ్ వెల్ as solid, guys, liquid are going to have molecule gap in between them or not? Yes. So how much gap can be neglected based upon a non-dimensional number? That number is called as what? Knudsen number. That number is called as which number, guys? Knudsen number. Knudsen number formula is what? Mean free path divided by characteristic length. What is the meaning of mean free path? Distance travelled by one molecule to strike to the another molecule. Let's say it is A. What is the characteristic length? Size of the molecule. Ante ఎంత ఉండాలి gap? A size of the molecule లో 100th part ఉండాలి. That gap can be neglected, and yes, that material can be regarded as which material? Continuous material అని మనం రికార్డ్ చేయొచ్చు. Okay na? So what is the definition of the fluid mechanics, guys? It is a branch of continuum mechanics under which liquid can be assumed as continuous materials. Liquid can be assumed as continuous materials. Chalo, pause the video and note it down, guys. Let's start with the first science, guys, that is fluid statics introduction. Okay, fluid statics. What is the meaning of fluid statics, guys? First of all, it is static. Static means rest. Fluid is a working medium. Okay, so fluid statics, it is a branch of science. It is a branch of science which deals with which material, guys? Which deals with fluid. What is the condition of the fluid? It is under rest, na motion, rest, because static is under rest, guys. Okay, now the first example what we are going to learn is design of dam. Let's try and understand, guys. Design of dam. From this design of dam, we are going to interpret, we are going to understand what is the distributed load and what is the uniformly varying load and what is the point load. Okay, first of all, observe the diagram, guys. This is the diagram that you are going to remember. Suppose this is a dam, and here we are having what, guys? Water stored in it. Let's say this is the water which is getting stored in it. So in a design of dam, you need to focus upon how the pressure is going to increase. Okay, formula for the pressure directly I am writing here. Pressure is equals to gamma times of h power 1. H power 1. Power 1 in the sense linearly they are going to vary. How the pressure is going to vary, guys? Pressure is going to vary linearly. We will write all the important points separately. Okay, what is the pressure distribution diagram? Observe here, this is the pressure distribution diagram that we are going to focus and remember. Pressure is increasing as the depth of water increases. Observe, guys, this is the pressure distribution diagram. Okay, pressure is going to be increasing. So the first point, the first important point is, what is this diagram called as? This diagram is called as pressure distribution diagram, guys, or hydrostatic pressure distribution also you can write. Hydrostatic pressure distribution diagram. First important point. Once you know about the hydrostatic pressure distribution diagram, by observing the diagram itself you can tell, guys, how the pressure is increasing. The pressure is increasing how, guys? Linearly. Pressure increases linearly. That is the second important point. Third important point now. What is the shape, guys, in terms of geometry? Shape of this loading diagram. Shape of loading diagram, is it in right angle triangle, na? Shape of loading diagram. Shape of loading diagram is right angled triangle. Right angled triangle. There are three types of loading. One is point load, one is uniformly distributed load, another one is uniformly varying load. So this diagram is similar to which type of loading, guys? Type of loading. It is similar to which type of loading, guys? If you have basics of strength of material, you know uniformly distributed load or uniformly varying load. It is uniformly varying load. It is uniformly varying load. If you don't know, have to remember now, guys. What is the uniformly varying load? Uniformly varying load, it is in the shape of what? A triangle. That's why these loads can also be regarded as which load? Triangular load kuda anachu. Emana chepani? Triangular load kuda anachu. Sir, how to convert a triangular load into point load or uniformly distributed load into point load? Observe here. This is a uniformly distributed load, guys. That is a rectangular load, you can also tell. Okay, this is a rectangular load. First of all, this one is W and this one is what? L. W and L. This is the representation. This is W and this one is what? L. And the load is called as which type of load, guys? It is and this load is regarded as uniformly distributed load. Okay, whereas what is a uniformly varying load? Uniformly varying load is also called as triangular load. Observe, this is a triangular load, guys. And this one is W, this one is length, na? This one is length and this one is what? W. Okay. Now, note point what you need to remember is area of loading diagram. Area of a loading diagram is equal to total load. Area of the loading diagram is called as what? Total load or shear force also you can remember. Okay. The next one you need to remember point of application. Point of application and where that load is adding, where that load is going to add, guys, act. Point of application of load is centroid of area. Centroid of area. Okay. Chalo. Now let's try and understand one more time, guys. What is this diagram looking like? Let me draw it one more time here. let's say this is a uniformly distributed load, W is acting per meter, and we are having here L meters. Okay, now let me draw it here. This is a uniformly distributed load. This is W and it one is L. What is the area, guys? Area is equals to, area of a rectangle is what? W into L now. Area of the rectangle is W into L. And where it is going to lie? It is going to lie at the centroid. Where is the centroid? At the center. Observe here, guys. This is the diagram that we are going to focus. Converted into point load. Total load is W into L. Where it is going to act? It is going to act at the center. That means at a distance of L by 2, at a distance of L by 2. That's how you have converted the UDL in terms of a point load. Okay. Now tell me, guys, what is the area for this triangle? Area is half into base into height, half into L into W, half into L into W or W into L. How you are going to put this one? This is the beam, guys, and where you are going to put the load? At the centroid. Where is the centroid? The centroid is at a distance of L by third, na? At a distance of L by third from the base. What is the load? WL divided by 2. Where this load is going to act, guys? Where this load is going to act? It is going to act at the centroid. That is L by 3 from one side, 2L by 3 from the another side. 2L by 3 from the another side. So that's how we have converted the uniformly distributed load into point load, uniformly varying load into point load. This is the first example of fluid statics, guys, that is design of dam. So what are the important points we have learned so far in the design of dam, guys? First important point, what is the formula? Pressure equal to gamma into H. How the pressure is varying? Linearly. What is this diagram called as? Hydrostatic pressure distribution diagram. Pressure increases linearly. What is the shape, guys? Right angle triangle. What is the type of loading? Uniformly varying load. How to convert the uniformly varying load into point load? Total load is equals to area, and where is it going to lie? It is going to lie at the centroid. Where is the centroid of the triangle? 1 by third from one side and 2 by third from the another side. 1 by third from the base, 2 by third from the apex. That is most actual answer. Okay, chalo, pause the video and note it down, guys.